Hi again. This time we're going to be fitting a quadratic, and we have three data points given to us on our grid here, A, B and C. None of them are touching the x-axis, so we don't know the roots of the equation. That pretty much rules out the turning point form, or the factored form. I don't think that point A is a turning point, because point A is 3 units horizontally away from point C, but only 2 units horizontally away from point B. So point A is not in the middle, it's not on the axis of symmetry. We cannot use the turning point form. We will have no choice but to use the standard form, and this one will be the most tedious one, I'm afraid. So standard form, as it says there, if we start an equation here, let's use point A to begin with. So y equals 2, and then we have a times x squared, where x is 3. So 3 squared, that's 9a, plus b times x, well, that's 3 for x multiplied by b, plus c. Equation 2, we'll substitute point b. So this time y equals 10, x equals 1. So 1 squared is still 1 times a, 1 times b, plus c. And then our third equation, if we substitute point C, y equals 5, x is 6 this time, so squaring that gives us 36a plus 6b plus c. Now for this one, we're going to have to use simultaneous equations, 3 unknowns, and I'll do the elimination method. I noticed that the value, or the pronumeral c, is the same in each one. So I could eliminate c if I did something like equation 3 subtract equation 1. I'll start here. So 5 take away 2 gives me a 3. 36a take away 9a, that would be 27a. That should work. Yep. 6b take away 3b is 3b, and c take away c is gone. Now I think I might do equation 2. Oh, that's a bad choice. I might do equation 1 take away equation 2. That's probably going to be nicer numbers. Equation 1 take away equation 2. So I'll have 2 subtract 10 is negative 8. Then I've got 9a subtract a is 8a. Then 3b subtract b, that's 2b. So we can see we have 2 new equations now. I'll call this one equation 4, and I'll call this one equation 5. Now, I think the pronumeral b will be the easiest one to work with, and I've got 3 and then 2 of them. So what if I go 2 multiplied by equation 4? So 2 3s are 6. 2 times 27 is 54a, and then 2 times 3b is 6b. Now what if I go negative 3 multiplied by equation 5? So negative 3 by negative 8 would be positive 24, and then that would be negative 24a, and then I would have negative 6b. Adding these equations should eliminate b. So 6 plus 24 gives me 30. 54a added to negative 24a gives me 30a, and then 6b take 6b is gone, so it looks like a equals 1. How nice. In order to calculate b, I think it would be best if I went back to equation 5. So I will sub a into equation 5. Equation 5 read negative 8 equals 8a, so let's try negative 8 equals, now 8a is 8 times 1, which is just 8, plus 2b. So subtracting 8 from both sides gives me negative 16 equals 2b, then dividing by 2, I have that b equals negative 8. So I have the value of a and I have the value of b. Now I think I'll go all the way back. Which one looks easiest? I think equation 2 looks easiest. It's just 10 equals a plus b plus c. So I will substitute a and b into equation 2. Equation 2 read 10 equals a plus b plus c, where a is 1 and b is negative 8 plus c. What do I get? Well, 10 equals negative 7 plus c. It looks like I should have 17 equals c. Now, altogether then, that means that my equation, y equals ax squared plus bx plus c, a was 1, now b was negative 8, and c was positive 17. So, if we were to check with technology, don't know why that didn't turn red for me, if I was to check with technology, I could type that quadratic in standard form onto my graphing calculator, and I should find that it intersects those 3 points nicely. And point A won't be on the axis of symmetry this time. I think the axis of symmetry will be a little bit to the right of point A. But I'll let you check that for yourself using your technology. Thanks for watching.